Hello, this is the first installment of my lecture series, Everything You Wanted to Know About Euler's Number, but Were Afraid to Ask, where I try to explain the significance of the number E. This is part 1, Compound Interest and Continual Growth. So let's start with reviewing the concept of compound interest. So as an example, if you get $100 and you invest that in a bank that's going to give you 8% of that annually as interest, then what you're going to get at the end of the first year is 100 plus 8% of 100, which is 100 times 0.08. And this is the same as 100 plus 8. So at the end of the year, you're going to get $108. Okay, very simple. And because it's compound interest, then during the second year, you're going to get 8% of that amount. So 108, so the next year you're going to get 108 plus 8% of 108. That's 108 times 0.08, which is the same as 108 plus 8.64, which equals $116.64. And again, because it's compound interest, then at the end of the next year, you're going to be compounded 8% off of this quantity, right? So you're going to get $116.64 plus $116.64 times 0.08, which is the same as $116.64 plus $9.33.12. Okay. And that, of course, is $125 and I can't even read my own writing there. 97 to that number. Okay. So we're going to rewrite this. We're going to do this again, but we're going to rewrite it a little bit and do some algebra just to make an important point. Okay. So let's start again. You have $100. And at the end of that year, you're going to get $100 plus 100 times 0.08. And let's just leave it there. We know that this equals 108. But let's just write it as this for now, except let's factor out the 100. Okay? When we factor out the 100, okay, this becomes 100 times 1 plus 0.08. So again, this is 108. This is what we get, but we're just going to write it like this, and we're going to compound this again. So we have 100 times 1 plus 0.08, in parentheses there, plus 100 times 1 plus 0.08 times 0.08. It's 8% of this whole thing. And again, we can factor out this, we can factor out this quantity, 100 times 1 plus 0.08, and we would get this, right? We factored out this, okay, and then we were left with this. But notice that since these two quantities are the same thing, we can just write them as squared. So now this is our new quantity that we're going to compound the next time. So we have this 100 times 1 plus 0.08 squared plus 100 times 1 plus 0.08 squared times 0.08, because 8% of that. And we're going to factor out, this deal, right? So we get this, which of course is equal to 100 times 1 plus 0.08 cubed. Okay, and of course you see the pattern here that every time, after every year when we compound, we're just basically multiplying our original $100 by this quantity. Okay, so the formula for compound interest, of course, is P times 1 plus R, that's the rate, the percentage of the interest, to the power of T, which is, how many years or how many cycles or whatever compound happen. Okay, pretty straightforward. So moving on, we're going to go to the next section of our lecture. Take a breath, pause, get some water. And I'm going to focus, okay, so we know that this is the formula for compound interest, but we're going to focus on this part of the quantity, okay? Let's put it down. And let's say that you're in a situation where you're going to get everything doubled. You're going to get 100% of your principal, right? And you're going to get 100% every year after just 1 year, okay? So that's basically, that's 1 plus 100% times 1 is 1, right? So that's 1 plus 1, okay? And after, you know, and how long was that? What was the time? Well, it's just 1 year. So after 1 year, it's 2. Great. After you have 2 times as much as what you started with. Okay. But let's suppose that you know, whatever financial institution you're working with says, yeah, we're gonna do that thing where we give you double interest, but we're going to actually compound your amount by 50%, but 2 times a year. So instead of compounding 100% 1 time a year, we're going to compound it 50% 2 times a year. Okay, and so that would look like multiplying the principal by this number. Okay, 1 plus 1/2 to the second power. And is that a better deal? Well, yeah, it is. You don't get 2 times whatever. You get 2 times 0.25. That's larger than 2. Okay. Well, let's suppose that there's another deal where you instead of doubling it and after 1 year cycle, you know, or compounding it half of the interest 2 times, you're going to compound a quarter of the interest 4 times a year. Well, then you'll get $2.44 about. Okay. Well, what about 12 times a year? Okay, we compound 1/12 of the principal, and we compound it 12 times a year. Well, then now we have this number, and this is going up. This is a better deal. Will it go on forever? Well, how about 365 times a year? We go, you know, 1/365th of the principal, but we compound that 365 times a year, and we get this number. All right. Does it go up and up forever? No, it actually limits, and the limit is E. Right? As we slice up the compounding cycles, you know, as many times as we want, and we approach infinity, and thereby compounding it that many times, we will approach the number E, which of course is this. Okay. So let's move on. And you might say, well, yeah, but what about, that was just if you get like 100% interest, which is not really realistic. That doesn't happen, does it? It's never happened to me. So what if we get 50% interest, you know, or just something lower? So as an example, we're going to do the example of, let's say it's 50% interest. Okay. So what is this? What will this be? Okay, as n goes to infinity. Well, just to make an example, just notice that 1 plus 0.5 over 50 to the 50th power is equal to 1 plus 0.01 to the 50th power. And we know that E is not exactly equal, but just go with me on this. E is is equal to or approximate to 1 plus 1 over 100 to the 100th power. Okay, or in other words, 1 plus 0.01 to the 100th power. Well, that means that this quantity, which equals this, is equal to this quantity, 1 plus 0.01 to the 100th power, but this whole thing to the power of 1/2, right? Because 1/2 of 100 is 50. Okay, so basically, this is the square root of this, and hence is the square root of E, right? So that's what happens. So our formula then for a continual compounding rate would be the principal times E to the power of R, to the power of our rate. So here, like, 50% was our rate, right? So we take it to the 1/2 power there, all right? And of course, that is to the power of however many cycles we have, how many years, whatever, all right? Okay, so here's the point. The whole concept of E, right, is it's related to the idea of continual growth. That growth, the rate of growth is based on how much you have. Okay? And as more grows, then the more the rate of growth there will be, right? And that is why, we find the number E in biology books and stuff like that. Okay, so here endeth part 1 of my lecture. Everything you wanted to know about Euler's number, but were afraid to ask.